All right, guys. So we're going to talk about how do you determine whether a quadrilateral is a special kind. So what I mean by that is it a parallelogram, a rhombus, a rectangle, a square, etc. So we're going to go over the properties that make it that specific quadrilateral, that specific shape. And so to start with, we start with the most basic, which is a parallelogram. So for a parallelogram, it states that both pair of opposite sides are parallel. So remember, the symbol for parallel on paper looks like two lines. On a diagram, we show things are parallel by drawing little arrows or little triangles, right? So these two arrows signify that this top and bottom side are parallel to each other. If I were to draw the same two arrows, now the reason I'm drawing two arrows is because if I were to draw one, then I would claim that it's going to be parallel to that one, which it is not. It's parallel to this, the one across from it, right? And so as far as congruent sides, the symbol for congruent is 2 equal sign with a squiggly on top. And so when it says both pair of opposite sides are congruent, to show that they're congruent on the diagram, we draw one line, and that same line is going to go to all the ones that are congruent to itself, right? So here the top and the bottom are congruent to itself, and the two sides are going to be congruent to itself, not the top and the bottom, right? And so that's why we use two different markings. The other thing that it says is that the opposite pair of both pair of opposite angles are congruent. So opposite doesn't mean next to each other. Opposite means kind of like straight across from. And so it says those two are congruent to each other, and these two are going to be congruent to each other. So that's what it says by the opposite angles are congruent to each other. The other thing that we get, I'm going to jump to this last one. It's stating that the consecutive angles are supplementary. So if we think back, way back, when we're talking about angle pairs, consecutive angles just means in the same, between the same, on the same side of the transversal, on the inside of the two lines, right? So in this case, it would be this angle there and that angle there. Those are my two angles that are consecutive, and it says that they are supplementary, which means that if you add them together, they equal, or that add up to 180 degrees. And that's going to be the same for these two as well. So these two, if you add them together, they equal to 180. That's what it means by consecutive angles are supplementary. The second thing right here that we skipped, it says the diagonals bisect each other. So what's a diagonal? A diagonal is going to go from one vertex to the opposite side, right? So that's one diagonal. And here is my second diagonal. So what this is saying is that both of these two diagonals are going to bisect each other. They're not necessarily equal to each other. It's just they bisect. So let's think about it. So if this, let's highlight it. So if this diagonal there is going to bisect the one that's going through it, that means that this side here is being bisected and it's equal to that side there, right? And so now we flip the order. So if we go the opposite way, then this diagonal is going to be bisected, and so these two sides are going to be congruent to each other. Okay, so that's what it means for a diagonal to bisect each other. So that takes us to the next shape, which is a rectangle. So if you notice, these first couple of properties are the exact same ones that we had for a parallelogram. The only difference is that for a rectangle, we add 2 extra properties. And so if we apply the same properties that we had for a parallelogram, we start by saying that both pair of opposite sides are parallel. So that is parallel to that. This is parallel to here. And not only are they parallel, but they're also congruent. So those two are congruent, these two are congruent. And furthermore, we have that the opposite angles are congruent to each other. So we'll talk about those in a bit. And then it says the diagonals, yes, they bisect each other, and the consecutive angles are supplementary. But if we look at these 2 extra properties that we're going to add here, it's saying that all 4 angles are going to be right angle, which means that at each vertex, at each corner, I have 90-degree angles, right? And so here it's easily see that both pair of opposite angles, not only are they congruent, but in this case, all four are congruent because they're all 90 degrees, right? The other thing is that the diagonals are going to be congruent. So now we get to the point where, yes, they are still bisecting each other. Whoops, let's try that one more time. So they're still bisecting each other because that's what we get for parallelogram, right? But now we know that the two diagonals are congruent to each other. They're the same length, which is telling me that if these are being bisected, right, and I say this has a measurement of 3, then all the rest of the parts for the diagonals are also going to be 3 because they're congruent to each other and they bisect each other, right? So that's the extra properties that we get for a rectangle, is the fact that the 4 right angles and the diagonals are going to bisect each other. Which brings us to our next shape, which is a rhombus or a rhombi. And once again, notice how the first couple of properties are the same exact ones as a parallelogram. The only difference now is we're adding 3 extra properties that make it a rhombi or a rhombus, which is that all 4 sides are congruent, right? So yes, we still have opposite parallel sides. So this is congruent to this congruent to this. Both parallel opposite sides are congruent. We're going to come back to that because we're adding a new property. And so that new property is here. So it says all 4 sides are not congruent. So if all 4 sides are not congruent, then I'm going to add the same marking to all of them, right? So that is going to be the same length as that, and that's going to be the same length as that one, and the same length as that one. So that's showing me that all 4 of these sides are congruent, they're equal to each other. The second part, or the extra property that we're getting, is saying that the diagonals are going to be perpendicular. Remember, symbol for perpendicular looks like this. And so what that means is that if they're perpendicular, that means that I have a right angle where the diagonals intersect. So I'm going to have a right angle there, a right angle there, a right angle there, and a right angle there, right? And so yes, the diagonals, they're still bisecting each other, but compared to the rectangle, they're not congruent to each other. So they're bisecting each other. So that's telling me that if this has let's go with 2 markings, and that means this one's going to have 3 because they're not equal to each other. They're still bisecting each other, but they're not equal to each other. And lastly, the angles, the opposite angles, they're still congruent to each other, but we get a little extra thing here. It says that the diagonals are going to bisect the opposite angle. So if the diagonals are going to bisect the opposite angle, what that's telling me is that this diagonal here is going to cut this entire angle in half, right? So these two are going to be congruent to each other, and because we get the fact that the opposite angles are congruent, then we know that these two are also going to be congruent to each other, right? So the opposite angles not only are they equal to each other, but the diagonals are going to bisect them, right? And so that only works for the ones that are crossed, right? So these, I guess you could think of these as these 4 angles are going to be congruent to each other, and these 4, we'll do this way, are going to be congruent to each other. Okay, and so that's how we determine, or that's how we distinguish that this is a rhombus. We're looking for these extra properties to make sure that that one represents a rhombus. Okay. And so that takes us to the last special shape, which is a square. And so notice how here those are still the properties of a parallelogram, and here now we're adding the properties. So these came from a rectangle, this came from the rhombi, and these came from a parallelogram. So in other words, the square kind of takes all of those properties together and puts them into its own shape, or its one shape, right? And that's what we get, a square. So square, if we put them all together, and we're going to go with these because those are the bigger ones. So it says, for a square, all 4 sides are the same. So that, though these two are congruent, these 4 sides are congruent to each other. We still have opposite sides being parallel to each other. That's not going to change. The only difference now is we also have the property saying that our corners, we have 90 degrees angles, or we have right angles. We also get the fact that these diagonals, not only do they bisect each other, but they're going to be congruent, right? So they're going to be congruent. Where is it? Here. They're going to be congruent. And we get the fact that when they intersect, they are going to be perpendicular, right? So we get another 90-degree angle there, and there. And the fact that they're congruent and they're bisecting each other is telling me that these parts of the diagonals are going to be congruent to each other. Okay. And so the last thing I want to let you guys know is, well, one more thing, sorry. So we also get this fact here that they're congruent to each other. So let's think about this for a minute. So if I know that one corner is 90 degrees and the diagonal is going to bisect it, what that tells me is that for a square and a square only, that right there is going to be 45 degrees. And if that's 45 and the whole thing is supposed to be 90, that's telling me that that little piece is also 45 degrees. Okay. And so how are these all connected? Well, they're all connected because, think about it this way. Okay. One, they are all quadrilaterals, right? So the tree kind of starts up here, if you will. So these are all quadrilaterals, right? And so the first one we can do is we can do a parallelogram. And so from a parallelogram, we can create a rectangle. So in other words, is a rectangle a parallelogram? Yes. Second one is we have a rhombus. Is a rhombus a parallelogram? Yes. But is a parallelogram a rhombus? It is not. It can be. It needs these extra properties, but by itself, it is not. And to get to the square, well, the square took on both of these properties, right? So when the question is asked, is a square a parallelogram? Yes. Is a square a rectangle? Technically, yes. Is a square a rhombus? Technically, yes. Right? So a square is kind of like a concoction of all of these, right? But you can't really go backwards. So we can't kind of go that way, right? So we cannot say a rectangle is a square because it's missing the properties of the rhombus, right? And same for the rhombus. We can't say a rhombus is a square because it's missing the properties of a rectangle, and vice versa. We cannot say that a rhombus is a rectangle for the reason that it's missing the properties of a rectangle. And same for the rectangle. We can't say it's a rhombus because it's missing those properties that make it a rhombus. And so one way to think of it is that you can kind of go down, right? So if you follow the arrows, those are the only possibilities that it can be. So a square can be a rectangle or rhombus in a parallelogram, but a parallelogram cannot be a square unless it has the properties of a rectangle and a rhombus.